Hello. Hey, everyone, thanks for coming. I've got a short demo, and we're going to put a lot of stuff in it, and I'm going to show some things that nobody's seen, and some of it is pretty crazy. So I'm going to jump in right now. The talk is called Unleash Your Game Cameras with Cinemachine. It's a lot more than just for cinematics. So what is Cinemachine? And I get this question asked quite a bit because it's a bit of a weird idea. So it's like you'd film something in real life, but it's not you. It's your army of camera operators. So when you think about the real world, cameras have a relationship with the subject. You look through the lens, you see the thing moves, you move the camera. That's a sophisticated setup. There's a guy with his hand on the focus. They're looking through the lens and they're making judgment calls on what's happening. In CG, up until Cinemachine, this is what it is. It's a camera and a thing, and they don't know anything about each other. That camera does not know that that's a sphere. It doesn't know if it moves. There's no relationship. So the guy, Gerald right here, we built this thing 3 years ago, and we decided to put a system of cameras together where the camera looks at the subject and makes informed decisions. And there's a lot of modules to this. This is something we've been building for a long time. Procedural composition, following, a third-person action-adventure free look system, 2D, target groups, custom blends, noise. It's big. There's a lot in here. I can't show it all to you right now, but I'm going to show you some of the big ideas. So the way you get it is in Unity, you go to the package manager, which is relatively new. It's this great idea. We've got so many different components in there. You just hit Cinemachine and you hit install. We've also got a bunch of example scenes in there. I encourage you to check these out because they show all of this stuff in action. And you just go Cinemachine, import example asset package. You got all this stuff. Look at all these scenes. A scene to show you how to do noise, a scene to show you how the mixing camera works, a scene to show you each of the ideas. And it's pretty fun. So we're going to show a number of demos here. I'm going to bounce out and show a movie right now. This is a game, it's called Halibut. It's still in development. It's all modeled, like in real life modeled maquettes. They're scanned and they're put into Unity. It's got something like 10 hours of dialogue. It's this like handcrafted, beautiful game with these like dioramas and sets, and when you play the game, and I'm going to show it live in a second, it looks like a Wes Anderson stop motion film. It's super cool. The entire thing is HDRP, and it's powered with Timeline and Cinemachine, because the blend between keyframe cameras and cutscenes and gameplay is completely fluid in this game. So if you're coding cameras or you're like keyframing them, it's not going to work because things change. And that's the essence of Cinemachine. It will film scenarios when we don't know what's going to happen next. So I'm going to bounce over, and we're going to see this live. So I'm going to jump right now. So here's the scene. This is Halibut. You got all this stuff, super cool. I'm going to go to the game and I'm going to hit play. The essence of what this game's doing is we're going from a Cinemachine gameplay camera that's procedurally tracking things to cutscene cameras, which are crafted for, you know, the master shot, over the shoulder. But because you're playing and we don't know what's going to happen next, we blend everything together with this thing called the state-driven camera controller. And I'll show you how that works. So here's the game. I'm make this a little bit bigger. So there's a little bit of dialogue, and then we pull into gameplay. So this is a static gameplay camera. Up here you can see this text that's up right by my mouse, right here. This is a Cinemachine debug. This tells you what camera is active. So as I walk up to this dude and hit enter, I'm blending to a suite of cameras. And these are all state-driven cameras. And what that means is we don't know how you're going to play the game. We don't know how long you're going to wait on each shot. So based on the animation state, we will call the different cameras. So if I go through this really quickly, the cameras work fine. If I go through it really slowly, it works. The animation states are calling the different cameras, and those are all handcrafted. You can actually tune all this while you're playing the game. So you can see we go from gameplay camera, we blend into the cinematic, and as I hit enter, we're cutting between the two. I know this isn't rocket science. I mean, this is one of the easiest things, but we did this without writing any code. We can tune it all in real time. You can hook up camera cuts with animation states like that, and that's traditionally been kind of a slow thing to do, and just do it while the game's playing. And it's so much faster. So I'm going to come out of here and we're going to go into, get my mouse over top. We're going to the hallway. And I'm going to show you, we blend this. Now, because of the integration with the HDRP, Cinemachine knows what you're looking at. Therefore, we blend and we get all the lens effects that are happening. So as you notice, as I walk closer, the background's gone out of focus. As I go down the hallway gets sharper. So the depth of field is dealing with and appropriately adjusting based on where subjects are in the world. You get all that for free. I'm going to go into the elevator here and open this timeline. And what this is when you hit a space, you hit the elevator, we play this timeline. The timeline's got the audio track in here. And this is a really neat way of working, because what you can do is you make lots of different timelines. You can put audio in them, you can put cameras in them, and you tie them to events in the world. So boom, I hit play, hit the door, triggers the timeline. So I'm going to go and show the next timeline that goes up. Oops. And we go inside. We trigger that. And what that's doing is that's blending between different timelines to move the camera up and to move the camera over. And this way of working with like cameras in timelines and embedding them and triggering them all together is this super fast way to work. So I mentioned the state-driven camera module. I'm going to get out of Harold Halibut. We're going to load up a new scene. And the main place that we first designed this stuff was for third-person action adventure games. So when you're a third-person action adventure game, you got an orbit camera. But then you want it to do something different when you run. And then you want it to do something different when you jump. And then if you go inside, you want it to do something different. And you want to do something different based on all these different gameplay things. So this is the standard assets character. It's just basic, programmer art. But check this out. This is where it gets really interesting. This is the state-driven camera module down here. And what it lets you do is take any animation state, and there's a lot in this project, and link it to any camera. So when he runs, play the run camera. When he jumps, play the jump camera. When he whatever, play the whatever camera. And then you can say how they all blend together. And that's this. So when I'm going from run to jump, blend quickly. But when I go from jump to run, go more slowly. And this is a matrix, and you can set this up. And anyway, I was on a project, we had 21 different free look cameras just for a character locomotion system. So if I hit play right now, you can see we're running. But if I sprint, the camera gets a little closer and we add a little camera shake. We actually change the post-processing. And then when I let go of sprint, you can see that we're blending back. So let's just go crazy. The game's running right now. While we're running, I'm going to open this up and go to sprint. And we're going to set the noise. We've got a procedural noise module, and this emulates handheld motion. So if I turn this on, this is a preview of what the camera shake is going to look like on the camera, because keyframing camera animation, handheld camera animation, is super slow and painful. This is how the camera's going to shake when I'm in spin mode. So I'm going to crank this up to just be ridiculous. so you can see it. So let's go amplitude. These are an overall scalar, 2 and 2. So now when I'm running and I go into sprint, the camera is going to shake a little bit more. And we can go crazy. And you can also notice that it's not just, I'll turn the guides off. We didn't just change that. We've got a new post-processing profile that lives here. So why don't we crank up the chromatic aberration and crank up the vignette, and that's what's going to happen just when I'm sprinting. Now this looks ridiculous, but you can see I'm tuning all this in gameplay mode. And you're like, okay, that's too much. Well, let's just pull it down to what you like. And all this is saved in play mode. And in the matter of hours, you can set up a crazy camera locomotion system, and you're not writing any code. So definitely check this out. There's a state-driven camera example in the Cinemachine example assets package, and it's super handy. Okay, so we're going to go and show you something that is one of my favorite things. Last year for Unite Berlin, we wanted to make a car commercial, and we wanted to do it as quickly as possible. So we had a few people working for a few days, and we made this video of a car commercial like a prototype. Like, what would it be like if we just didn't give ourselves much time? And there was some late nights in there, but it was a lot of fun. And we made something that looks pretty good considering the time that we put into it, but it's using some really interesting Cinemachine techniques that I'd like to share with you. So we will let this open up. I'm going to jump ahead. I'm going to talk about the next demo. No, I'm not, because I didn't need the time. We'll talk about the next demo when the next demo comes up. So this is the auto scene. Let me just configure a couple things at the start. The idea was we wanted to come from the city and end up in the country. And the car was going to drive from the city world all the way to the end. We wanted to do all of these different camera cuts, all these cinematics, and some really advanced color and post-processing, and some really specific color grading. So actually, I'm going to jump ahead and talk about this. Who here has listened to any of the Unity Dots stuff? Does that ring a bell? Data-oriented text, that's cheating. You work for the company. Okay, you work for the company too. It turns out that programming languages and hardware have really diverged. Programming languages do not write that well optimized instructions for hardware. So we have built something called Dots that allows for performance gains that are completely bananas. And after this, I'm going to show you a demo that is unthinkable, like just completely impossible to do before the existence of Dots. So please stay for that because it's insane. Okay, so here's a car scene almost loaded up. So we've got this big timeline here. And what I'm going to do is, these are activation tracks for each of the levels being like the environments. So I'm just going to put the different worlds, like these are like the different vignettes, the locations. We start out in the city, and we go through these different locations. And let me just close this. So the gist of it is, we start out here, we drive along, we go through these different locations. This is all rendering real time on my machine. And I wanted to show you some of the camera moves in here. That was this like dolly track that came through. And if you look at it in the world, you can see we've taken this dolly track and we've constrained it to the car. So as the car drives, the dolly track goes. And then we've keyframed the camera moving down the dolly track. So as you drive, now the camera's spinning around. Now the camera is procedurally targeting the car, and I wanted to target the logo. And then we have the camera noise on there. So what you get is a shot that's procedurally composing the car, moving down a dolly track, but then with camera animation on it too. Let me show you another example of that that's got a bit more information. This shot is this long sweeper across, and then the car drives away. And if you look at the dolly track, you can see that it goes through the world. There it is. See that line? And as the car goes down, the camera moves down the dolly. But this is where it gets crazy, because the camera's moving down the dolly, but we're procedurally composing on the car. So the camera is automatically orienting to keep the car exactly at that point on the screen, because that's where I want to compose it. But you can animate that. So what we're doing here is this curve here is the keyframing of the procedural composition. So what that means is that's where I want the car to be on the screen. And we've got damping controls to decouple the composition of the car so like it feels a bit more like a real cameraman. But look at this. Keyframe camera dolly down the track, procedurally keyframed composition, and that's not very good. I want the car to be in the middle of the screen right while that happens. So I'm going to put this right in the middle. And what's really interesting about this, and it's a bit of a, you got to get your head around it, is we've now decoupled layout and animation. So you can change animations and the cameras will still figure it out. So if I take this car animation and I slow it down, the director comes in and says, the car's going too fast. I slowed that, see, I just held shift. This is the car animation track, and I just moved it to here, and I've slowed it down by 3%. The shot still works because the camera knows that that's what you want to look at. So after you do layout, you can change cameras around, you can change animations around, and the cameras still figure it out. And because post-processing lives on all of the shots, you can change your color grading. It all lives everywhere. Like the depth of field here is bananas. So why don't I just fix that? That lives right on this shot. So at the very end of this, we've got these, I'm going to just reset this. The camera pushes in, we blend to post-processing profile that's too bright, and we go out. And that's because these clips overlap. So if I make them flat like this, look at this, I just go camera, and I cut. And I cut to this shot with too bright a post-processing, too bright color grading. But when you overlap clips, they blend. So maybe I don't want this to be overblown, maybe I want it to be not quite so bright, but I want this to be black and white and darker and contrasty. We have the move, and we blend into the black and white cut and contrasty. All your post-processing lives on each shot, and this is a super fast way to work, because you craft your ideas and they live on the camera, and your post-processing changes. Okay, shit, I got 3 minutes. I gotta show you this thing that's really, really, really crazy. Thank you. This is dots. I'm really excited to show you this. Cameras are expensive. Procedural composition is expensive. Raycasts are expensive. Procedural damping, that's expensive. Pre-dots, we could run about 20, 30 cameras, and then it's starting to get expensive. Just slow down too much. Post-dots, we can do more. A lot more. So forgive the programmer art. We have this scene with a shark, and we're going to spool up a lot of fish. We're going to spool up 500 fish. Each fish has a procedural camera that's following it. The camera is doing a raycast, and it's doing shot evaluation. If something gets in the way, it'll cut to the next best shot of the shark. The fish are the black things. The cameras are the orange things. We're running 500 fish at 106 frames a second. Wait, did I say 500? Sorry, I meant 5,000. 5,000 ray trace cameras. I know, I'm like my delivery is too schlucky, but that's pretty crazy. It's 5,000 procedural cameras, 5,000 procedural fish. Each fish is swimming. Each camera is throwing a raycast. Each camera is evaluating the fish. 50,000? Let's do 50,000. 50,000 cameras, 50,000 raycasts. Raycasts are expensive. 50,000 raycasts, 50,000 fish that are swimming. And this is how much time it takes. For the cameras, less than a millisecond. Like, this is a game changer. Oh wait, did I say 50,000 cameras? Ready? I know, I'm sorry. Super corny. Okay, we're gonna do 500,000 ray traced cameras. Like, before the laptop melts down. And it does take a second. And it doesn't run that fast. But it's 500,000 ray traced cameras, 500,000 fish swimming. And this might melt through the desk right now. It's just like this ball. But, give it a sec. This is silly, but we got 500,000 raycast cameras and fish, and it's running at 3 frames a second on my laptop. So it's going to be really exciting to see what people do with this. And you might think, well, why this many cameras? And I'm out of time, but there are some really exciting things for why you'd want to do that many cameras. And if you want to hear more about this stuff, take a picture of this slide. The top one's the Cinemachine landing page. The next one is Cinecast, and that's what we're going to be doing with 50,000 ray trace cameras. And then the third one's me. You can follow me on Twitter. And thank you for your time. Thanks so much.